Hi everyone. We got special right triangles activity. I'll have you partnered it up by now and need a ruler that we can measure with and write straight lines with and a protractor. And I want you to get ready. And I want to get ready too, so I'm putting on the glasses. Not that you can see that. And first thing I have you do is, I'm not measuring, but I'm just drawing a segment AB with the straight edge. After you draw that segment, I want you to draw a 30, let me mark A and B like that, A on the left, B on the right. I want you to draw a 30-degree angle with vertex at point B, and I want you to go that way with it. Point B is the vertex. I need a 30-degree angle. Here is 30. I'm going to put that mark right there, and I'm going to draw that. And I want to... Alright, clipboard's not a great idea. Seemed like a good idea at the time, but... Okay, get that all lined up nice and mark your 30-degree mark, and then got my point set on B, and I'm going to draw through that, and I want to make sure I'm above A enough, because now I want to make a right angle there. And in order to have right angle, I'm lining up A right along that side there. I'm going to put the 90-degree mark right there. And you do this. So this is 90 degrees. This is a 30-degree angle. And if you're doing a little math in your head, you figure, well, there's 60 degrees left for this. So this is one of our special right triangles. A 30, 60, 90. And I've done step 3. I've drew a perpendicular straight up from A, and where that crosses, we're going to call that point C. I'm going to measure AB. And I want you to do the same. I don't expect you to have the same measurements as me, but I do want you to measure. Now as I look at this, I see measure of AB 6.5, 6. Looks like AB is 6.6 centimeters. And I'm going to measure BC. So I measure BC here. Mark that a little bit. I see that as 7. Move this out of the way. There's 7, 5, 7.6, 7.7 looks like the best thing there. That is segment BC, which is 7.7 centimeters. And the last one I'm asking you to measure is segment AC. And when I do that, that is really close, but not quite. So I'm going to go AC is 3.9 centimeters. Now step 5, right here, says make the following two ratios, AB over AC. That would be 6.6 over 3.9 centimeters over centimeters. Now those centimeters will cross out just like common factors would. And I'd like to thank whoever left their calculator. This came, whoops, 6.6 divided by 3.9. And look at the nice little picture on the back. Who is that? 6.6 divided by 3.9, that is approximately, I'm going to go just to the nearest tenth, 1.7. Now that's mine. You figure out yours. I'm going to take BC over AC, and that is 7.7 over 3.9. And I'm going to round to the nearest tenth again. And 7.7 divided by 3.9, I'm getting 1.97. Now if I round to the nearest tenth, that's approximately 2.0. Just to the nearest tenth. Okay, at this point, I'm going to read step 6. I want the other person, one person made this, we did all this. I want the other one of you to make another 30, 60, 90 triangle. You saw how we did it first. And I want you to use different sides. So when you draw AB, all you have to do is make sure AB isn't the same length as what the other person did. And you'll mark that D, E, F. And have your... And then, we'll pause this for a second and let you get that done. We'll resume. And we are resuming where you will multiply your FD side by the two ratios. What did you get here? What did you get here? Next thing I want you to do is measure what FE is and measure DE. And we'll pause and figure out and we'll make a connection there. That's it for that one. Okay, we're back, and we're going to draw an isosceles right triangle. Isosceles right triangle. I need a right angle. So I'm going to start with my... We're going to use this. We could construct it, but I think I'll just, for now, just... use the protractor instead of a compass. So I'm drawing this. Now, it needs to be right, so I'm going to mark a right triangle. And I'm not in love with that point, so I'm going to erase it for now. And I'm going to go to, I like 5. Johnny Bench was number 5. So I'm going to go 5 centimeters here. And that's where I'm going to put point B. And I'm going to measure right here. I'm going to put a 5 right here. So I'm calling this A. That's my right angle. And I'm going to call this C. Okay, and then you just draw your connecting. This is 5 centimeters here, so these two sides are the same. So it is an isosceles right triangle. We're going to make a ratio of the hypotenuse over the leg. We already know the leg is 5 centimeters. So let me measure the hypotenuse. You don't have to make yours 5. You can use a different length if you'd like. I'm getting... let's see, around, that really looks like 7 centimeters there. And I can go 0.0 and 0.0, doesn't matter, just showing the position I'm using. Those cancel. I don't think I need my calculator for that. I get a ratio of about 1.4, exactly 1.4 with those numbers. All right, partner. Make a different size isosceles right triangle. Use something different than what your partner did for the legs. I want you to, we should be pausing there. We're back. I want you to measure a leg and multiply that by the ratio that your partner found in step 2. And then I want you to measure the hypotenuse. Now at that, we're going to go delve into the theorems a little bit of the special right triangles. Now this is an isosceles right triangle. It's also known as, do you remember, and what's half of, here's 90, 180 minus 90 is 90. So I have 90 for two equal angles. Remember, if the sides are congruent, the opposite angles are also congruent, so it's a 45, 45, 90 triangle. Alright, that describes the activity, and we'll discuss some of the things here later. I'll talk to you in a moment.